Geometry, Section 4.6, Isosceles, Equilateral, and Right Triangles. By the end of this lesson, you should be able to use the properties of isosceles, equilateral, and right triangles. We already know that isosceles triangles are triangles that have two congruent sides. However, there's some other pieces of the triangles that we can name and identify. We have our legs. The legs would be considered the two congruent sides of your isosceles triangle. Now, you have two legs, the third side is going to be called your base. And this doesn't matter whether the base is at the bottom or if it's been rotated in some other way. The angles that are on each side of the base are your base angles, and the third angle is going to be called your vertex angle. Now we have what's called the base angle theorem, and that theorem says that, we can move this arrow over, this says that if two sides of a triangle are congruent, then the angles opposite them are congruent. And it's called the base angle theorem because if you notice, the two sides of the triangle are the legs, and the angles opposite them are the base angles. So if you see an isosceles triangle, you know you have two congruent sides, but you'll also have two congruent angles as well. And what we'll also find is that the converse of the base angle theorem is also true. So if you find that you have two congruent angles, you can say that you have two congruent sides. Let's see how this works. So for this next question, it's asking you to solve the variables in the following diagram. We have a triangle, we see that we have two congruent sides, and we have some measures given to us. Since we see that we have two congruent sides, we know that the base angles are going to have to be congruent, and our base angles are the angles that are opposite of our congruent sides. So this means that both angles A and angle B will have to be congruent, which means we can set up an equation to solve for x. We can say that 75 is equal to 5x. We can divide both sides by 5, and we find that x is equal to 15. Once we have that information, we know that this 5x is equal to 75, this is 75, and all the angles in the triangle add up to 180, which allow us to solve for y. So we say 75 plus 75 for two congruent base angles, plus 3y, which is our third angle, is equal to 180 degrees. When we solve this equation, we find that y is equal to 10. Now we also have a corollary to the base angle theorem. A corollary is a rule or another theorem that follows from a previous one. So our base angle theorem said that if I have two congruent sides, then the sides opposite them will also be congruent. So we can say that looking at these two congruent sides, these angles across from them will be congruent. What your corollary is going to say is that if you have an equilateral triangle, then it's equiangular. And what this says is our third side that's congruent to the other two will have an angle opposite that's congruent to the other two. So in other words, if a triangle is equilateral, then you can say it's equiangular. And just like our base angle theorem, the converse of this corollary is also true. So if you're given an equiangular triangle, you can say that it's going to be equilateral. Finally, we have our hypotenuse-leg theorem. This is our hypotenuse-leg congruence theorem. And this says that if the hypotenuse and the leg of a right triangle, so the hypotenuse and leg of a right triangle is going to be congruent to the hypotenuse and leg of another right triangle, then we can say that the triangles are congruent. This will be our fifth and final way that we have to prove triangles congruent. Seeing how this works, here's a proof, and we can take a look at that. Now note that this theorem, the hypotenuse-leg theorem, is only going to work if you have right angles. So we had a right angle here, right angle, which means we had a right triangle. And in this next example for this proof, you are told that RTV, this angle here, is a right angle, and we're given that SVT is a right angle. So now we know that we could potentially use side, 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 angle, angle, side, or angle, side, angle congruence postulates theorem, or we can also now use the hypotenuse-leg theorem, whichever one will end up doing the best job for us. So we also are given that our V is congruent to ST. Starting our proof, we can list our two givens. Our V is congruent to ST, and we also know that RTV and SVT are right angles. Since our hypotenuse-leg theorem only works when we have right triangles, we're going to need to say that since we have right angles, we know that those triangles are going to be right triangles. So we can say that RTV, and triangle SVT are right triangles. And the reason why we know this is because the definition of a right triangle tells us so. Once we've established that, we can notice that the two given segments that were congruent, RV and ST, the ones that are highlighted, those are both the hypotenuse of each of our right triangles. So what we need to do is we need to find that either RT and SV are congruent or TV and TV are congruent so that we can fulfill the hypotenuse leg part of our theorem. And the way that we can do this is that we see that TV is congruent to TV. And the reason for this is the reflexive property. So once we've stated that we have a right triangle, we have shown the hypotenuse to be congruent to the other hypotenuse, and we have another leg to be congruent, we are done, and we can go ahead and say that these are going to be congruent, the triangles, by the hypotenuse leg congruence theorem. And that is pretty much how our hypotenuse leg theorem works, which means it's time for a joke. And our joke for today is, why didn't the skeleton cross the road? And the reason why the skeleton didn't cross the road is because he didn't have the guts.